things from the book here we'll start off with to get our juices flowing. We're wrapping up chapter 15, heading into home here. Next week the finals. We've got chapter 16. And so this is our real ups and downs. I don't know what's going on with this. It's possessed. Do a little restart here. Okay. So Great Depression, 1910, all the way through today. And so we definitely had some more volatility back then. That's what kind of led to the potential for maybe the government could be involved and reduce volatility. So then we get into here, and it looks like maybe we've seen some success. But what we're going to go over today is that part of the success could come from better information in the economy and the way we form expectations. But there's kind of the ups and downs. So percentage change in real GDP over time, right in this 2 to 3% level. If we kind of took the average, we're somewhere in there. Again, here with more volatility, but in that 2 to 3% growth range. All right, now here is what we ended on yesterday. We looked at 10 different leading indicators. And so my last thing I told you that should be in your notes was they combine all 10 of those variables together, kind of squish them into what's an index number. This line is that index kind of squished together and traveling over time. And so check out what happens here is that the index of those indicators peaks and goes down, and then this bar here is actual recessions in the United States. And so we do see that this one starts to go down, and then we head into recession, right? This one goes down, recession, recession, and so that's what we mean by those leading indicators. But there's also not a perfect correlation with the timing of when that's going to happen. So here, this one peaked at 8 months prior, and then the recession occurred. 9 months, 14, 18, 9. So it still doesn't give us a lot of precision. And then furthermore, we've also had some turns that didn't lead to recession. So it might indicate, like here, this is a turn, but it didn't lead to recession, right? And so there's points where the indicator peaked, but it didn't lead to recession. So it's not a perfect indicator. It just gives us a little bit of a indication that there's a potential recession coming, but it's not foolproof. And furthermore, we don't know the distance between of when it's going to happen. Does that make sense? But it does give us some information. So every once in a while you'll see the index of leading indicators has taken a turn, and the headline might read recession coming or something like that. Well, that's kind of dramatizing it, but yes, it is true that there is that connection, and that's why we went over it. Okay, questions or comments there? Let's see. I was thinking about putting one more up here, but I don't think we will. Okay, so let's get into forming expectations. How do you guys form an expectation about the future?
Based on what you know about past events.
Okay, yeah, good. So past events would be one area that we're doing, right? So let's kind of start that off here. How do you form an expectation? So one, look at past. Right? So we're kind of looking backwards here. What's been happening previously? All right, and so what else? How else do you form an expectation about what you think is going to happen besides looking at historical information? Somebody other than Jesse? Yeah, Tim.
If you have data.
What's that?
If you have data, you look at
Okay.
data.
So kind of like data what we had, right? Like there's current event data that might be relevant. So whatever the past number is, you know, if we were predicting, you know, let's take inflation here. So here we are in, what are we in? April of 24. If this is your information here, what is your expectation about, you know, May of 24? Well, looking at the previous data on inflation only, it might be a safe guess to say it's here, or maybe you could be a little fancier and there seems to be a trend that's going up a little bit, right? But if this is at 3.7%, if this is inflation and we're measuring time here, then we wouldn't be using past data. We wouldn't be thinking, oh, it's going to be 5%, right? Or it's going to drop to 1%, right? So looking at past data, we kind of think, well, it should be somewhere probably close to that, right? So look at the past data and trends. But number two, we also might want to look at current data. Look at current event data. And so maybe we are just about to, tensions in the Middle East are growing, and so we might be going to war or something, right? So if we're on, all of a sudden things look a little different, maybe then this number would change bigger than what we predict just off the basic trend, right? So those are kind of the ways we're going to try to form expectations. And so the two things, or two ways we're going to identify from the text here, two ways to look at expectations. So two ways to form. So number one is called adaptive expectations. Under adaptive expectations, we're going to rely on that historical stuff the most. So that's where we're going to put most of our weight. So we're going to use data from the recent past of observed outcomes to base our future predictions, or our expectations about what the future is. So from our example here, our actual or expected inflation rate, so pi e, so we've used this in the past. Remember the superscript e is my way of saying expected. So inflation expected is based on the previous period's inflation. That was actual. And then number two is what's known as a rational expectation. A rational expectation. So rational expectation uses all available information. To form an expectation, including current policy and current events. In addition to historical, or maybe I'll even write this. In addition to historical. Okay, so it may seem kind of obvious to you, but a lot of times we'll do this type of thing where we're just looking at previous data and we make our prediction off of the past rather than thinking about maybe some of these current conditions. And it turns out it's going to have a big impact on how the economy performs if we get people thinking about the world this way rather than this way. All right, so what's some outcomes? So rational expectation outcomes. Number one is that they're going to be correct on average. So we kind of have an equal possibility of being right or wrong or high or low. So we've got the bell curve. Maybe some of you remember the bell curve. A lot of people remember the bell because it's kind of pretty. But most people can't remember what the dimensions are of the bell. So draw yourself a little bell, the bell curve. And the important parts of the bell curve are this tippy point. And does anybody know what happens at the tippy point, what we're measuring over here on the vertical axis? Would have saw this in statistics class, kind of a normal probability distribution. It would be kind of the fancy word we put on the bell curve. So it's representing the most probable outcome. So this here, we're measuring probability. And this outcome here of, let's go ahead and put inflation. So our inflation expectation is, what was it again from last time? 3.4% if I remember right. So the gurus in the macroeconomic arena, probably the Council of Economic Advisors and the Federal Reserve, had predicted 3.4% inflation. And so the argument here is that they used a rational expectation to come up with that prediction. And so the most probable prediction of the upcoming next month's inflation was 3.4%, right? According to what they did, whatever that probability is. So were they right? Did they turn out to be right from, was that yesterday that we did that? Or 2 days ago? Yesterday? Yesterday, the article? So were they right? No, did anybody remember what it was? I think I already wrote it, maybe. 1.6. No, it was higher than that. That was, what was that? That was, that was GDP. Yeah, GDP grew by 1. They were wrong on that one too, but yes. 3.7. So it turned out they were wrong, and the actual ended up being 3.7% was the actual. Okay, so now, what does the bell part mean? So the 3.7 would have been, connected up here somewhere. What does the bell mean in relationship to 3.4? So they ended up being off by 0.3%. But what does the bell part mean? Did they underestimate or overestimate? They underestimated, right? So note here, this is an underestimate of the actual. All right, back to the bell. Could they have had 3.1? Could they have overestimated?
Yeah.
Yeah. And so they could have overestimated as well. And so if this is 3.7 and this is 3.1, if I drew this really carefully, which I didn't, what the bell curve says is that they had an equal chance of being too high or too low. They had an equal chance of being too high or too low. So the bell implies equal chance of being too high or too low. Okay, questions or comments on that? All right, so on average, we are doing good, but we're actually likely to be wrong. And this brings in our outcome number 2, which is we expect there to be small forecast error. Number 2, using rational expectations, we'd expect there to be small forecast error. So when we're off, we're not going to be off by the moon, right? So 3.7, I mean, 0.3%. It was at least in the ballpark. We had equal opportunity being this, but it wasn't like 2% and 10% when we're kind of in a month-to-month basis. So the height and fatness or thinness of the bell kind of gives us this. So back to our picture here. Imagine we could have had a bell curve that looked like this. A big fatty. There's a big fatty. And the big fatty means, wow, I'm saying 3.4, but it might be plus or minus 3%, right? If you have a big fatty up here. So a big fatty means a lot of variability, a lot of unknown, a lot of potential error. And so the reason we hang our hat on rational expectations is that if we're taking all the information that's available and using it, we should be, small forecast error. So using all information, we will squeeze out all knowable things and be left with kind of the true unknowns, true uncertainty. If we're using all the information, it's like, well, can't we do better than this? The answer is no. Some things are not knowable, and that is what we call true uncertainty. So life is a risk, right? And so the best we can do is try to minimize some of that uncertainty. All right, so that was all put together by Robert Lucas, and he's a Nobel Prize winner, and he did this in the 70s, because prior to that, people were thinking, we can just use our models and get the kind of traditional outcomes that we were doing. So this is what kind of spurred it. So the Phillips curve, let's just say spurred rational expectations theory. So the Phillips curve is kind of an interesting one. So a guy named Phillips, A.G. Phillips, around 1955 did a long run study. So a guy named Phillips, A.G. Phillips, around 1950s, did a long-term study of inflation and unemployment in the UK, in the United Kingdom. It was actually 100 years, approximately 100 years worth of information. And he graphed out the data points from over 100 years. And so we have inflation up here on the vertical axis and unemployment on the horizontal axis. Did you guys get caught up to that point here? Okay, so here's the punchline. He found that, in 1867, it was here. And in 64, it was here. 100 years, 100 dots of data points. There, do something like that on your paper. Now, if you're a researcher, which we hope you guys will start to have some critical thinking skills under your belt here looking at this thing, what would you say is the relationship between unemployment and inflation with this long-run study over 100 years? What does the data tell you about the relationship? It's negative, good. Okay, so and what do you mean by negative, Justin?
That when unemployment rises, then GDP goes down.
Inflation, but not GDP, but inflation goes down. Yeah, so there's a trade-off. So a negative relationship, it looks like when unemployment's high, prices are low, and when prices are high, unemployment's low. So there seems to be this trade-off, and so he did a statistical relationship and came up with what's called the Phillips curve. And the Phillips curve, so just kind of draw some sort of average line. I didn't even do a very good job. Looks like I made it a little too high there at the tail end, but it doesn't really matter. As long as you got something downward sloping. And so the Phillips curve, PC, the Phillips curve shows a potential trade-off between inflation and unemployment. As Justin pointed out, a negative relationship. And I just remembered, I do want to announce something. I'll try to send out an email, but who knows if I'll remember. All of you guys are entitled to what I call one freebie on your test. So in all of your MindTap scores, if you want to retake one test, you just need to email me and I will reset it for you to take it again, and you won't lose any points. So it's a freebie. So you can make up one test with the freebie. So if you want to do that over the weekend or whenever, we'll let you kind of trickle in. I'd like to get all of those done by Wednesday of next week. So you got a little bit of time, but everybody gets a freebie. All right, so there's our relationship. All right, well now, this starts coming off of the heels of World War II. Did you have a question, Mass?
Yeah, did you mean done with the test by Wednesday or done emailing you for which test?
Done by Wednesday is what I was kind of looking for. So that way you're not interfering and going into the final. You guys can just be done and grades be done, right? Because next week's finals week, so. All right, so we come off World War II, government's getting bigger, policymakers are using government as a tool, and what do you think politicians, what's the goal of politicians again that we learned from chapter 6?
Stay in power.
Stay in power. Get into power if they're not in power, and then once they're in power, stay in power. What do you think they like better? If they had to pick to be at, let's just call it point A or point B in general, what do you think is better for the politician? A or B? Tim?
A.
A, why?
Because unemployment is low and inflation is high, so he gets more money and the people are more pleased.
People are more pleased. Yeah, I think the votes is the main thing. But yes, they, higher income or whatever, there's less people. So if we think of it in terms of voters, and this isn't too big of a deal, we're not going from up to 20% inflation, because all of a sudden you're not going to be real popular then either. But if there's kind of the general range, and this is from 3.4 to 3.7 or up to 4%, whatever, kind of a smaller trade-off, then this looks kind of good. And so what we had going on in the 1950s and 60s in the United States is politicians favoring spending policies that we've already learned tend to be inflationary, right? But they're like, well, as long as unemployment's low and I still stay in office, who cares? And so that was the pattern. And that pattern worked for a while, but then as Milton Friedman predicted in the 1960s, it's not sustainable. And so now, what happened in the 1960s in the United States, or the 70s rather, late 60s into the 70s, is all of a sudden we're here, and 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 here. And it's like, who would have guessed? The Phillips curve isn't right? So how are we off of the Phillips curve, right? So that was the kind of the question mark, and so we learned that the Phillips curve is not really a trade-off that's sustainable in the long run, but rather is based off of expectations. And so on your papers, if you kind of want to do the same thing, we can highlight here, 1970s, USA, we are off the Phillips curve. Okay, so now we're going to use this rational expectations theory to explain that. So now we're going to draw two graphs side by side. You do have to know this for the final exam. So get yourself down a good graph here. So the one to the right is going to be our normal aggregate demand, aggregate supply model starting in a long run equilibrium. And let's just say at a price level of 100 to keep the numbers easy. And of course, we're at the full employment level of output. And off to the left, we're going to have, so this is the goods market, like we've been doing. And now we're going to have the Phillips curve. All right, so using rational expectations, we're going to look at things a little bit differently here. So where is the economy going in the future? We're going to listen to the news. What's the Fed doing with monetary policy? What is Biden and Congress up to with fiscal policy? And citizens, through reading newspapers or otherwise, and I know not everybody has to do it. You can just listen to some things. But basically, people form an expectation of where they think the economy is going. So we're not there yet, but that's where we think the economy is going to go. All right, and then based on those expectations, this is where we're going to shorten the lag time between output price adjustment and resource price adjustment. Now, resource suppliers and everybody else is expecting that the economy is going to be here over the long run. And so they're expecting there to be a price level of 4%. Oops, 104 is what I meant to say. A price level of 104 or 4% inflation. So now when we start engaging in wage contracts and other deliveries and other things, everybody's kind of taking into account 4% inflation, right? Kind of similar to what we just did with we were expecting 3.4% inflation and it ended up being 3.7%. Maybe I should have did that, but I'll just leave it at 4 for now. So we're expecting 4, right? And so now resource prices and output prices are going to start to adjust right away. And so based on those expectations, the short run aggregate supply curve is going to immediately shift to a new level. So this is based on a wage of $10.40. This was a wages, and when I use the word wages, remember I'm just talking about resource prices in general. People are going to be baking into their thought process a 4% inflation rate because that is what they're anticipating. All right, so if we are correct and the actual aggregate demand curve moves to where we expected it to be, notice what happened was nothing in terms of any fluctuations with output. We just got 4% inflation, like everybody was expecting. So in other words, everybody's kind of going about their business, living their lives based off this 4% inflation, and they make their adjustments in their lives, and so nothing happens in the real economy if our expectations are correct. But is it likely that we're going to be correct? No. We're likely going to be wrong, but with rational expectations, we have an equal chance of overestimating or underestimating where we're going to actually be. So now the economy plays out and we learn where we go. So with this one, let's say that the actual rate ends up going to here. AD2 is the actual. I'll put the little actual up there. So we thought it was going to be here. We ended up here. So did we underestimate or overestimate? Underestimated, right? And so now what happened to real GDP? Did it go up or down because of our error? Where's the actual state of the economy? It's always at the intersection of what two curves? Aggregate demand, the actual aggregate demand curve, and the short run aggregate supply curve. Bingo. So we thought we were getting 4%, so we changed our behavior and our contracts and everything to get 4%. We were wrong, and so it was our wrongness that got us a bump up in GDP. Okay, so let's tie this into this Phillips curve analysis over here. So over here, let's go ahead and have a Phillips curve. But now this is going to be the short run Phillips curve. And a special anchoring spot we need to have is the natural rate of unemployment. So remember, this is the natural rate. So a healthy economy is experiencing their natural rate when the economy's at full employment. So now there's a connection between these two graphs. The full employment level of GDP, this one, and this are connected. And at the natural rate, we formed an expectation of inflation of 4%. And I see that I didn't put, make sure you put a little pi e up here. This is the expected price level, which then gives us our expected level of inflation of 4%. Now, since we were wrong, the actual price level grew to 5%, or 105, I should say. So this is the actual price level, which means there was actually 5% inflation. GDP is high, so does unemployment go down or up when GDP grows? When the economy's growing, are there more people working or less? When the economy's growing, is there more people working or less? More, which means unemployment is down. Unemployment's down. So check it out. Now we are at an unemployment that's lower. So we're at U2. U2 is connected with Y2 here. And we ended up with inflation that was actually 5%. And now we have an explanation of where the Phillips curve trade-off came from. Looking back now through the lens of expectations, 100 years, there wasn't this monetary policy stuff goofing around. There wasn't much inflation. So if you go back and look at inflation, this was a fairly narrow range of prices changing over the 100 years. So basically, people just lived their lives and they didn't think about inflation, right? But once inflation started getting higher in the United States, they did start thinking about those expectations and built them in. And so this is the story of how we get a Phillips curve looking relationship through expectations playing an important role in the economy. So this was groundbreaking. Again, he won the Nobel Prize in Economics for developing this rational expectations because it explained where this would have come from, and it also explains the trade-offs and policy formation and how government policy that's expected if it's known, doesn't do much for the economy. It's kind of neutralized, right? So again, if we are perfectly right with the economy, then government policy doesn't have any real effects. It's just kind of neutralized through our expectations. And certainly the advent and growth of the information age has been huge for that, right? And we could go back to even the radio, TV, news channels, but then the internet and us walking around with the ability to get data from everywhere makes this argument even more and more compelling. Okay, let me pause for questions. Anything on the mechanics? Let me just kind of start with that. There's a kind of a lot going on here. Good? All right, I'm going to add one little thing at the risk of giving you too much, but I think I want to put down another alternative is what if we underestimated? So your book does this too. So what if we were here? So if we overshot, what happened to GDP? Recession or expansion? Recession. So now the new black aggregate demand and red short-run aggregate supply curve is here, which means we had inflation of 3% at 83 and output that's below. From our Phillips curve here, that means we're sitting at unemployment that's higher than normal and inflation that was lower than expected. All right, so your book doesn't do this, but I'm going to add it on. I don't think it's going to confuse you. I'm hoping it helps you. The long-run Phillips curve is no relationship. The long-run Phillips curve is vertical. No relation outside of unanticipated inflation. So we were expecting 4%, and now, because of what the Federal Reserve did, and they bought a bunch of COVID bonds and blah, 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 let's say now we're expecting 10% inflation. Well, the 10% inflation is up here somewhere, and so the Phillips curve would shift up. And so the intersection of the long run and short run Phillips curve is always anchored at our expected level of inflation. And I'm not going to monkey up that anymore, but I think that helps there. Okay, questions or comments? All right, our last important topic of this one is debt and deficit. We've talked about this a lot, so that's why I kind of saved it to the end. So, what's the difference between debt and deficit? Would you be able to, for the final exam, explain to me the relationship, maybe even in one sentence, of debt and deficit? Jesse, you want to give a try?
It's debt if you owe it to someone. It's just a deficit if you simply don't have the money for it.
No, I don't want. There's too much loaded into that one. I mean, there's parts of what you're saying are correct, but it's not precise enough. The relationship between debt and deficit. So, what's the relationship between G and T? Is that the debt part or the deficit part? Well, we did G and T, government spending and taxes. So deficit and debt. Which one's bigger if you run a deficit? G or T? G, right? So G is bigger. Governments spend more money than they collected in tax revenue, and then that gets us into issuing bonds. So let me put it as a definition in one sentence for you that you can memorize for the final exam. So the national debt is the accumulation of previous deficits. So the key point is deficits are year by year. They are a flow variable, and debts are a stock variable. So let's just do a couple of them here. Let's do 2021, 2022, 2023. And so here's G, here's T. And so if this is 5 trillion and this is 4 trillion, then we had a deficit of 1 trillion, the difference between the two. In 2022, if we spent 7 trillion and we only had 3 trillion of taxes because they shut the economy down due to COVID, now we have 4 trillion of deficit that year. That's how much we were short with tax collections. And then in 2023, we spent another 7 trillion, but some people were back to work, and so maybe we had $5 trillion of tax collections, giving us $2 trillion of deficit. So, over the 3-year period, we had the debt grow by 4 plus 2 plus 1 is 7 trillion. And so here, the national debt grew by 7 trillion over the 3-year period. Okay, so any questions on that? So for the last 40, 50 years, again, we've talked about this so often, I thought this was an easy one to end with. We've had these things piling up in various levels. One time in about 40 years, we had this guy a little bit bigger than this guy, right? But otherwise, in 40 years, the United States has continued to do this to the point where our national debt is over 30 trillion now. So it continues to grow, and it doesn't look like there's any slowing it down at this point. So it's up to you, the young people, to save the world.
Isn't it always?
All right, yes it is. All right, well, call it.